Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a very nice, interesting equation with complex numbers. What is a complex number? Well, a complex number can be written as A plus BI, which is also the name of this channel, and A and B are real numbers. And I is the square root of -1, or you can define it as such, I squared equals -1. If you're new to complex numbers, go ahead and check out my lecture videos. If you like algebra, number theory, and trigonometry problems, go ahead and check out my other channel, Cyber Math, Cyber with an S. Great, so let's get started. How do we solve an equation like this? Guess and check. Replace z with a plus bi. Sure, that could be one of the methods. Why not, right? So let's go ahead and start with that. First method, we're going to replace z with a plus bi because it can solve many problems. Second, it's the name of this channel. Isn't that cool? So let's replace z with that, a plus bi times e to the power I times a plus bi. And that's equal to I pi over 2. So here's the trick. You have an exponential on the left-hand side and not an exponential on the right side. So you either have to turn the right-hand side to an exponential, or you kind of need to do something else. Maybe we can do this. What is e to the power I times theta? Theta is an angle, which is also called the argument. And Euler, thanks to Euler, because he's the greatest, we can write this as cosine theta plus I sine theta. So this one, we should be able to write it as follows, right? Which is a plus bi times e to the power I theta. So in this case, this is theta. So we're going to get cosine of that plus I times sine of that. And of course, this whole thing needs to be multiplied by a plus bi. And that should give us I pi over 2. How nice. So when you distribute this, you're going to run into some problems. Real problems. I mean, real and complex problems both. You know why? Because how do you take the cosine of a complex number? That's the trick. So that's going to be super problematic. Maybe we can try to turn this into an exponential. Don't you think that's easier? Probably. So I just gave up on this method. I don't even know where this is going to end, right? So it wasn't even planned initially, by the way. My plan was just to show you a single method, but then I thought about it like, why not, right? Even though it doesn't get anywhere. So let's go ahead and try to write this as an exponential. How do you write a complex number as an exponential? Well, if you have a number like w, a complex number, you can write it as r times e to the I theta. In this case, of course, we're not talking about the same theta here. It's a different theta, right? How do you do that? Well, we do need the modulus. This is the absolute value of w, and this is the argument. So if you think about a complex number in the complex plane, which is also called the argand plane, which is a fancy name, we basically need to know two things. The angle theta, and of course it can take many values because you can add multiples of 2 pi to it. Again, I go over all these things in lecture videos. I made a playlist. So the second thing is the absolute value, right? So how do you find the absolute value of a number? Well, easy. If you have a plus bi, the absolute value of a plus bi is, or should I say x plus yi, because I'm not going to take the absolute value of that. Am I? Maybe, who knows? But if you take the absolute value of x plus yi, let's just say, it will be square root of x squared plus y squared. And that's from the Pythagorean theorem. If you think about it, if this is x and this is y, you get the idea, right? This would be x plus yi. So let's go ahead and try to find the this absolute value of this expression. Since it's a multiple of I, its absolute value is pi over 2. So we should be able to write this as pi over 2 times e to the power I theta. Theta is going to be like, if you think about I pi over 2 is positive, so I pi over 2 is going to be here because its real part is 0. You got that? And it's going to make an angle of pi over 2, so it's going to be pi over 2 again. That's interesting, right? So now we can go ahead and maybe compare these two things. Let's try that. We have a plus bi multiplied by e to the power I times a plus bi, and that's equal to pi over 2 times e to the power I pi over 2. So can we safely say that a plus bi is supposed to be pi over 2, and then a plus bi is supposed to be pi over 2? That's exactly what it is, right? Because look at this. These things correspond. Look at that. Awesome, right? So a plus bi is pi over 2. But what is a plus bi? That's z, right? So we got z. We were looking for z and we got it. What's the answer? Pi over 2. Well, isn't this supposed to be complex? Yes, its imaginary part is 0. And so a is pi over 2, b is 0, and it's all good. Okay? Let's go ahead and take a look at the second method, and please let me know which method do you like better and why. Let us know in the comment section down below. Okay? And thank you for watching. We're not done yet. Don't go anywhere because we're going to do the second method. So, what was the problem? We had z e to the iz equals I pi over 2. Now, the second method is actually really cool because we're going to use a special function, which is called Lambert's W function. What is that? Lambert's W function is a special function, obviously, which is discovered by Lambert, probably, right? I think a French mathematician. And he said, okay, if you input t to the t, you get t with my W function. It's such a cool function such that we don't really have an explicit expression for the inverse of this function, but now we do have it, and it's called W. Make sense? Okay, great. So if you apply it, you can get t, but you don't have t e to the t on the left-hand side. Why? Because if this is your t, then this is not t. You got that? Okay, so what does that mean? I need iz. Let's do that. Let's multiply both sides by I. So that's going to be iz times e to the iz equals I times I pi over 2. Nice. What is I pi over 2? I pi over 2 is I squared times pi over 2, and I squared is negative 1. Remember, I told you that before. Very important. So we get negative pi over 2 from here. And now this gives you iz times e to the iz. So let's go ahead and distance these a little bit because we're about to apply, ta-da-da-da, are you ready? Lambert's W function. Let's apply it on both sides. And when we do, we're supposed to be getting something nice from here because look at this. This is my t. So the result, or coffee, whatever you want to call it, that should be iz from here after applying Lambert. And then on the right-hand side, we have w negative pi over 2. Here's the trick. How do you find w of negative pi over 2? Well, I was thinking about using Lambert's W function, right? I use WolframAlpha. Do you think WolframAlpha can figure this out? Well, actually, I asked this question to WolframAlpha, like, can you solve it? It gave me a solution, but it didn't simplify it. That's the problem. And you'll see all of that. In a little bit, I'm going to show you. But here's the thing. To be able to simplify this, we need to bring it into the form t e to the t or c e to the c. C is a constant, obviously, right? And how do you do that? Well, here's the thing. You can go ahead and try to split up pi over 2, or negative pi over 2. And remember, it was written as I times I pi over 2. If you know that I in the complex plane is right here, and its argument is pi over 2, and its modulus is 1. In other words, I can be written as e to the power I pi over 2, and guess what? That does the trick. Now, this is the same thing as negative pi over 2, so if you apply Lambert's W function on it, here's what's going to happen. You're going to be getting w of I pi over 2 times e to the power I pi over 2, and this is equal to iz, and when you apply it immediately from here, you're going to get I pi over 2 because that's your c, right? Do you see what I'm talking about? Hopefully, that's I pi over 2. Now the i's cancel out because I is not 0, and you get z equals pi over 2 as before. Remember, I told you, we already got the answer with the first method, but this is the second method. Now we're going to check WolframAlpha. What do you think? WolframAlpha, I already told you, could not solve the original problem, but I prompted it differently, and it was able to. Was it able to solve it? Let's find out. First of all, this is what WolframAlpha gave me as a solution. I don't like that because I do need a specific simplified solution. But anyways, this works, I guess. And then when I asked these two questions, what is w of negative pi over 2? And what happens if you multiply it by negative I? Because that's what you need to isolate z. And yes, this is the exact result. WolframAlpha was able to solve it after so many prompts. Too bad. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out Cyber Math and A plus BI, and bye-bye.